Hello, my name is Layla Abedrabbo, and I'm currently a senior majoring in environmental engineering studying at FGCU. This is my final project where I've conducted my coding from the software known as Matlab, specifically using Matlab App Designer. My final project design and code focuses on the mathematical and physical motion of a projectile following a parabolic trajectory. It describes the motion of an object that is launched at an angle from the ground and follows a curved path. In this context, the study of a projectile motion provides an insight into the effects of various physical parameters such as velocity, angle in degrees, maximum height, and maximum distance. Overall, the projectile will be based on the initial velocity and the angle theta of the launch. These factors will be utilized to calculate the components of the initial velocity vectors by using sine and cosine. Based on the initial velocity vectors, we'll create the time of flight, which is the time a flight is a duration of the projectile, by multiplying the vertical initial velocity vector by 2 and dividing it by the gravitational acceleration. Thus creates a time vector of an evenly spaced points between 0 and the time of flight. Most importantly, the definition of the x and y coordinates of the projectile from each point is displayed from the code. I will display the code view. Here it displays the theta, time, x and y components that will be used, overall with the distance and height. And now I will show the design view. As shown in the display, the distance of the projectile travels horizontally, as you can see here in the x-axis, and the distance covered by the object on the vertical axis, as you can see here, the y-axis, and both are defined as the horizontal distance in meters and the vertical distance in meters. However, the vertical distance also has a composing force with acceleration, thus gravity is formed, and is another factor to consider when conducting the equation for the vertical distance as shown in the code. Lastly, to consider the x and y coordinates of the projectile that accompanies the factor of time in seconds into the equation as shown in the code again. The x-coordinate of the projectile represents the overall distance in meters throughout the launch, while the y-coordinate represents the maximum height in meters that the projectile will reach. And now for the time of demonstration. Okay, so I will run the code right here. This is the UI figure. And as you can see here on the top left side are the input components, which shows the velocity in meters per second and the angle in degrees. Now, a student can type in a value for the velocity component, but only a value that's between 0 and 100 meters per second. So hypothetically, I will input 10 meters per second. Once that is complete, the student can then input a value for the degree value. However, the angle must be between 0 and 90 degrees, so I will hypothetically add in 20 degrees, as shown here. And now lastly, the student can click in the Launchpad button right down here, which will launch. Now what we see here is that the trajectory clearly shows that it's launching process from the ground to its maximum height and distance. Once it hits the ground, we can see the exact maximum distance and its height. So it does take a little bit of time, but at least it shows like the demonstration of the whole projectile. And okay, now we can see that the maximum height in meters shows to be 0.5962 meters, and the maximum distance in meters is 6.55 meters. And this greatly shows a demonstration for students to observe an example of a combination of a mathematical, physical, and even an engineering concept of an object thrown in a projectile trajectory. Thank you so much for listening. I hope you all have a great day. Thank you so much.